identity on its own. It doesn't have the translation there. So why would that happen? If this has these changes and it's multiplied by the rotation matrix is to the identity, and the scale matrix is also the identity. Let me try just having the translation on its own. Now the shift is there. And so now I can replace this with the model matrix. Okay. So when I take the translation matrix, this must not be the right way to multiply. That's the only explanation. Because multiplying by the identity shouldn't destroy these. Or am I somehow not knowing translation times rotation times scale? There has to be a different way to multiply. There has to be. Is it matmul? I think I've used dot before. Let me see. It's the matrix product. Alternative matrix product with different broadcasting rules. Matmul differs from dot. Can't multiply scalars, and stacks of matrices are broadcast together. Okay. Dot probably does like element-wise multiplication or something like that. Okay, so now it worked. Can this take multiple? No, I can only take 2. Okay. Alright. Well, I guess I'll have to do it a way like translation times rotation and then multiply that again times the scale. Pretty ugly. At least that's working. Okay. Now, if I'm lucky, if I call this with different translations, I think I'll be able to simulate the camera moving. So here I'm doing star camera position. I think what I want to do, this should be a vector, I think. Just like a translation vector. I can do star of that. Okay, so this should not work, I think. Wait, did I not spell this right? Translation is not defined. Oh. I should default this to that. And I think in this case it makes sense for this to have an object as the default argument. I think. Maybe it doesn't actually. That's pretty much always a bad thing. Let's say if this is none, that's what I'll do it. Let's do this the standard way. Then don't use the camera position, use that. Great. Now I gotta have a view matrix with a translation. is going to vary. I have translation. Is going to vary. I have translation. It's gonna start at origin, I guess. And then I'm gonna want to increase this maybe in an updater or something like that. Yeah, but I don't want to have to deal with updaters right now. Let me try just making this like right or something. Just to show that I can influence it. And that just annihilated it off the side of the screen, I guess. Oh, then I should do else. Trans. Oh wait, it doesn't need the else. Well, I guess you can't do it with just right. Oh, it needs the z coordinate. So let me do empty.array. And I'll have 0, 0, 11. And it's still not there. What is the difference here, though? Oh, I didn't even pass it. This should be like this. Okay, so now it appears. Now what I'll do is I'll have a global variable for the amount of time. Which isn't that great of practice, but you know, we're going to do it anyway. And then I have time plus equals 1 over 60. And now let me just put in time here. And I need a global. Maybe I could make it a self.time or something. And not embed at the end. If I just wait here. For say 10 seconds. No, same thing. So why is that not being updated? Also, I can't cancel out of this. So why would that not be updating? I wonder if this is just not being increased fast enough? I'm gonna increase this by 1 on each frame, and then print it. Oh, it's not changing on each frame. Is there seriously no way to pause out of this? I have to decrease the time. So this is only happening once per frame. So I would want to do this increasing time somewhere within the render loop. So pretty much here. For mesh and scene.mesh, it's mesh.render. I guess it will be possible to update the mesh. Update the mesh while it's already a mesh. This is actually something where I think you would need an updater. Which is annoying. So let me just try setting this firstly. This will have the shader. And so I can write to the shader's view matrix like this. So maybe what I'd want to do is... Oh, and since this is a mobject, it probably doesn't have updaters the same way mobjects do. Yeah, I'll just have to do this inline. It doesn't have updaters the same way mobjects do. Yeah, I'll just have to do this inline. I'll have to do something like basically this logic. And the shader will be the mesh.shader. So that I don't know if time is defined here. I guess it's not, but I'll call this ShaderTime. So it doesn't conflict with the time import. And pass in that. I think I need the global here. Okay, so let me make sure that doesn't crash. I guess it doesn't. And stop printing so much. Close to these windows. Don't need to print that either. And I don't need scene.py open. Okay, so now I'm going to try to increment that time in the OpenGL render and see if that helps. So do shader time is equals 1 divided by 60. And I guess that global needs to be here. Okay. So that does look like the camera moving to the right, which is good. Let me increase the time on that. What did I do? Oh. I don't need to set this uniform here at all, since it's being set in the renderer. Okay. And then if I increase the X and the Y, okay, so that makes sense too. I wonder if it'll look like it gets smaller if I increase it this way. No, it looks like that doesn't happen. Or subtract it. Okay. I think what's gonna have to happen is in order for this to work well from user space, I will have to have a concept of updaters for meshes. So let me see how the scene handles updaters right now. Or I can make the rotation and scale matrices work properly. Let me try that, actually. I want the 4-dimensional ones. So I think I just need this with then the row and column from the identity matrix. So this would do the X, Y, and Z rotations. I'll just copy that over. So I'll say if you have an X, I'll just default these to none, Y and Z. Actually, that could get a little annoying because I'll have to multiply together a bunch of rotation matrices. I do an X rotation. I want to do the X one for now, actually. Yeah, I'll do only the X one for now. And so 1 cosine, negative sine. One cosine, negative sine, sine, cosine. Okay, I think that's all I need. If this is done in radians. Alright, so now in the renderer, I'm going to try to pass this a translation. And I won't pass, or a rotation, and I won't pass a translation. I guess there's a problem with this. What did I do? Argument 0 of none type. Oh, this is only if X is a none. Or this should just default to 0. And it isn't an object, so I think that's safe to do. Okay, so now if I pass in a rotation, which is a number, then I can pass it in here. I'll just say X equals some rotation. And that should affect the rotation matrix here. So let me try to do that in the renderer. I'll just do ShaderTime. And I'll increase it, then I'll have rotation equals camera rotation. So maybe this will have a rotating effect. And it does actually have a rotating effect. The difference being that, or the reason it did that in a kind of weird way, is that X rotation means it's rotating around the X axis. Where did this go? Anyway, this is rotation around the X axis. And the X axis is going to the right. So if the camera is rotating around its own X axis, it'll be the camera looking up. It'll have the effect of the camera looking up, which means the shape will move down. So that makes sense, basically. Now this is only X rotation matrix, I should say. Like the rotation matrix. We'll take X equals 0, Y equals 0, Z equals 0. I'll have to do a matrix of multiply these. And return the X rotation matrix, Y rotation matrix, etc. Right now, I'll just have it return the X rotation matrix. Then, I think the Y rotation matrix would be more interesting. Or slightly more. So this is just basically doing it around the outer entries. So this will go here. This is a 1. this 0, put that there, this 0 here, and I think this is right. Just not aligned, so it looks kind of weird. So now, oh, I edited the wrong one. I'll just call this one Y, I guess, and this one X. And give it a Y variable name. I think this is all a lot easier if you use quaternions. But I don't know quaternions. Okay, so X, this should really just be rotation X, rotation Y. Quaternions. Okay, so X, this should really just be rotation X, rotation Y, etc. Or I guess X rotation, Y and Z. Those Y rotation. Great. So then it'll multiply these two together. Let me see if I broke anything. And of course I did. So it should be, I'll say X rotation. Okay. If I change that to Y rotation, then it rotates off the other side, which makes sense. Makes some sense. I'm gonna do the Z one. That'll probably be the last thing I do for this stream. It'd probably be helpful, pretty helpful to learn quaternions. Since I'm, from what I've seen around OpenGL circles, quaternions are a lot easier to use than rotation matrices. Okay. So then these are in those, basically those rows and columns. So we have 0, 0, and this will be 1, I think. Okay, then I'll replace all these with Z's. And then this, I have to add in the Z matrix. Oh, let's see. Wait, comma. Right? Okay. X, Y, Z. Now let me try doing Z rotation. If this is using all three, which it's not. Okay, and that makes sense too. That if the... So the Z-axis is coming out of the screen. So when the camera rotates around its Z-axis, the camera rotates counterclockwise. And so things it's looking at appear to rotate clockwise. It's a bit weird since the circle isn't affected. So I do like if I combine an X rotation and a Z rotation. see what happens then. I guess it did kind of what I expect. Sure. Okay. Well, all these rotations are working now. Yeah. Cool. I definitely have some work to do to get updaters working on these. Updaters working on meshes and stuff. And there's just a lot of bugs that are piling up with this OpenGL stuff. Yeah, but I'm going to do that on a later stream, I guess, since we've only got 5 more minutes left. But thanks a ton to everyone for watching.